Have you ever wondered why Mars looks so dry and empty compared to Earth? There is a secret battle happening high above the red planet, where invisible forces tug at its fragile atmosphere and steal it away bit by bit. Let's join the adventure and find out what's going on. Long ago, Mars may have had rivers, lakes, and maybe even enough air to support life. Evidence from rovers and orbiters shows dry riverbeds and minerals that only form in liquid water, clues that Mars was once a wetter place. But today, most of its atmosphere is gone, and the surface is dusty, cold, and barren. So, where did all that air go? The answer lies with two cosmic players: the solar wind from the sun and Mars's lack of a protective shield. Here on Earth, we're lucky. Our planet has a strong, invisible shield called a magnetosphere. This shield comes from our planet's swirling molten iron core, which creates a powerful magnetic field. The magnetosphere acts like a giant umbrella, protecting us from the constant stream of charged particles sent out by the sun. These charged particles make up the solar wind. Whenever the solar wind slams into Earth's magnetosphere, most of it is deflected harmlessly away, and our precious atmosphere stays safe. But Mars is different. A long time ago, Mars's molten core cooled down, and the global magnetic field faded away. Without this shield, Mars was left exposed. So what protects Mars now? Mars has what scientists call an induced magnetosphere. It's like Mars quickly throws on an invisible bubble suit made from magnetic lines whenever the solar wind blows by. This bubble is created because the incoming solar wind interacts with particles in the upper layers of Mars's atmosphere, generating magnetic forces that temporarily surround the planet. But this suit isn't tightly wrapped like Earth's magnetosphere. It's thin, fragile, and easily pushed around by the solar wind, which can get very rough and rowdy, especially during solar storms. The solar wind is like a fast, invisible river of tiny, charged particles, mainly protons and electrons, blasting out from the sun in all directions. When this stream hits Mars's thin bubble suit, it often punches right through, scraping against the top of the Martian atmosphere. This allows the solar wind to steal particles from Mars's air, mainly in the form of atmospheric ions like oxygen and carbon dioxide, and sweep them away into space. Scientists have studied this process for decades, using spacecraft such as Europe's Mars Express with its Aspera 3 instrument and NASA's MAVEN orbiter. These robotic explorers collect and send back data about the ions, electrons, and even neutral atoms that are escaping from the planet. By combining their real-world measurements with advanced computer models, scientists can simulate and understand the invisible struggle happening over Mars. There's an exciting twist. Sometimes the solar wind's magnetic field and the induced magnetic lines around Mars line up in just a specific way. When this happens, Mars's bubble suit becomes even weaker. Think of it like a gap opening up in an umbrella just as a rainstorm hits. The solar wind can now reach even deeper into Mars' atmosphere, grabbing and carrying away even more particles. Over time, this slow-motion game of cosmic tug-of-war, in which the solar wind is much stronger than Mars's bubble shield, leads to a steady loss of the Martian atmosphere. In fact, this erosion has gone on for billions of years. Scientists estimate that Mars lost the majority of its atmosphere and surface water during its ancient past, mostly due to this ceaseless escape. As the air thinned, Mars became colder, and liquid water on the surface could no longer exist for long. Any lakes or rivers dried up, and Mars's landscape turned into the dry, frozen desert we see today.